Welcome to the exercises of lesson 4. And we'll start with an exercise about mathematical induction. This will definitely come at the exam, and then just remember there are 2 questions to be answered, 2 parts of the proof to be made. First step is prove that the statement is true for the first element, and then second, assume that it's true for some element in the middle, and then try to prove that it's also true for the successor. And so remember those 2 steps. And in this exercise, step 1, what is the first element? That's always the first issue. And then you see there's a sum from I is 1 to n. So the smallest n you can deal with is 1. So we have the first step, sum I being 1 to 1 I square, and that should be, we need to prove that that's 1, because n is 1, times 2, times 2 times 1 plus 1, that's 3, divided by 6. Okay, if we look at this right side first, then it says 1 times 2 times 3 is 6, divided by 6 is 1. Okay, and if we look at the left side, the sum of only one element, and then we'll look at the element square, so 1 square equals 1. Okay, check. That's never a problem. So step 1, the only issue is there, what is the first element? And then basically it's administration. Okay, second step, and that's the assumption. So step 2, assume, and then let's make it a different color. So assume that for some element in the middle, and let's give it a name, so let's give it a name k, I square equals k times k plus 1 times 2k plus 1 divided by 6. So the blue thing is an assumption. You may use that one later on in your proof. And that's what we need to prove, is that it's also true for the successor. So that the sum I is 1 until k plus 1, and that's the successor, equals, so we need to prove that that is k plus 1 times k plus 1 is 2 times 2 times k plus 1 plus 1, that is 2k plus 3. And that one divided by 6. So that's what we need to prove. Okay, let's try to do that. So we start on the left. Proof. So the sum I equals 1k plus 1 I square equals. And then now we need to reason to the right part, and we can use our knowledge of the assumption. Okay, in the assumption we know something about the sum until k, That is k here. Okay, so we can try to reason this sum into a sum with k. So equals I being 1 until k, I square. But now I've left one element out, that is k plus 1 square. Okay, use the assumption. So now we can say that is k times k plus 1 times 2k plus 1 divided by 6 plus that one left out element, k plus 1 square. We have a divided by 6 on the left part. Let's make it similar. So k plus 1, 2k plus 1 plus, and then I have to multiply the right side with 6, 6k plus 1 square, and that complete one divided by 6. So now the 6 here and the 6 there is done. So I have to worry about the middle part. Let's try to simplify. So that would be, now we have a k plus 1 here and a k plus 1 there, and there's a square, so I can do k plus 1. outside brackets, and then on one element I have k times 2k plus 1, and on the other side I'm still left with 6k plus 1, and that divided by 6. Okay, so k plus 1 is also done. So this one is done and this one is done. We have the same issues there and there. So now I have only this small part in the middle left, and I like to have this one in the same shape as k plus 2 times 2k plus 3. Let's just try. I will leave the blue ones outside and I'll only continue with the middle part. So that would be 2k squared plus k plus 6k plus 6. We have a k squared, 7k and 6, so that's 2k squared plus 7k plus 6. And that would mean, oh, now we are getting somewhere. That is 2k plus 3 times k, 2k times k gives me the 2k squared. 3 times k gives me part of the 7k, so I have still 2 left. 2 times 2k is 4, and then let's check the 6. 3 times 2 equals 6. So this middle part I have now transformed in this bottom part. So in total, this was on a piece of paper on the side, I have now managed to prove that it's k plus 1 times k plus 2, I just switched them around, times 2k plus 3 divided by 6. And then let's go up, and then we'll see that this is exactly what we needed to prove. K plus 1, k plus 2, 2k plus 3. So, big line. And we have demonstrated it. With error demonstrandum. So, with the help of mathematical induction, we've proven that it's true for the first element, proven that it's true for the successor, if it's true for some element in the middle. Done. On your exam, because this is quite a complicated proof, if you just put down the format already, so if you already write down, I have to prove it for the first element, and you do that, and then you say, okay, I need to prove it if it's true for some element, I need to prove it for the successor, then you already get points, because what we like to see is that you know how mathematical induction works. Exercise 4.5. Now we have a sequence with a given property. And they first like us to give some values of A1, 2 and 3 just to get a feeling of the sequence itself. So A1 would be 3 times A0 plus 2. So that would be 3 times 1 plus 2. So that would be 5. Okay, A2 would be 3 times A1 plus 2, so that would be 3 times 5 plus 2, that would be 17. And A3 would be 3 times A2 plus 2, so that would be 3 times 17 plus 2, so that would give us 53. And so apparently n plus 1 is 3 times the one in front of him and then added with 2. And now apparently it applies that A1 is 2 times 3 to the power of n minus 1. Okay, looks complicated. Let's check it for the ones we already made. And so for A1 it would mean that it's 2 times 3 to the power of 1 minus 1. So that would be 2 times 3 minus 1, that would be 5. Yeah, check. A2, that would be 2 times 3 to the power of 2 minus 1. So that would be 2 times 9 minus 1 would be 17. Check. And A3, I'm quite confident that this will work. that would give us 2 times 3 to the power of 3 minus 1. So that would give us 2 times 27 minus 1, and indeed 53. Check. And so, okay, we're quite confident that what they tell us is true. So let's try to prove it with the help of mathematical induction. Step 1. To prove it's true for the first element. Well, in fact, we already did that, huh? So A0 is the first element, and we need to prove that A0 would be 2 times 3 to the power of 0 minus 1. Well, A0 is 1 according to the property, equals 2 times 3 to the power of 1. 0 is 1 minus 1, so that would be 1. Okay, done. Step 2. Let's make an assumption. So assume that it's true for some element in the middle. So assume that for some element in the middle, and let's call it k again, then ak is 2 times 3 to the power of k minus 1. And then we need to prove that it's true for the successor, so that ak plus 1 equals 2 times 3 to the power of k plus 1 minus 1. And that's what we need to prove. Proof. So we start on the left. ak plus 1. And what do we know? Yeah, we know something about it with the help of the property. ak plus 1 would be 3 times ak plus 2. Now we can use the assumption. So that would be 3 times. And we know something about ak because we have this assumption here, the blue one. So that is 3 times 2 times 3k minus 1 plus 2. So that would be 3 times 2 times 3k minus 3 plus 2. And now we see 2 times a 3 here, so I can put the 2 up front and then have the 3 inside the 3 to the power of k, and that becomes 3 times k plus 1. Minus 3 plus 2 will make minus 1. And we're already done. Look, 2 times 3 to the power of k plus 1 minus 1. That's exactly what we needed to prove. So done. So this was an easier proof than the previous exercise. Just remember, step 1, step 2, then nothing can go wrong. In the next video, we'll continue with the exercises of lesson 4. See you in the next video.